Welcome to lesson 4.3. There's a lot covered in this lesson. There's a couple things that we're going to be discussing. So let's start off with some definitions. Now, these definitions should be familiar to you. If they aren't, I suggest you take a little bit of time outside this video to refresh on them a little bit better. But the most important ones are right here. And then this set right here. So, absolute maximums and minimums is the biggest or the smallest y value of the whole function. So if you look at the whole entire thing, it is the biggest y value or the smallest y value in the whole graph. Compare that to a relative maximum. It's a y value that is greater than or equal to all nearby y values. So a relative maximum means in that area, it's the biggest value in that area. So for example, if I had a function like this, that would be a relative maximum. It's bigger than all the y values around it. But this would be my absolute maximum. It is the biggest y value in the whole graph. And then you could do the same thing with minimums. So this would be the relative minimum, and this would be the absolute minimum, sorry. So hopefully that makes sense so you can figure out the difference between those two. Now, this last one is also really important, critical numbers. And this is something we're going to be using for the rest of the chapter. A critical number is an x value at which f exists, but f prime is either 0 or undefined. That's a critical number where f prime is 0 or undefined. And we'll talk about that more in a little bit when we do an example problem. Now let's do the extreme value theorem. This one, just like our other theorems, does have a condition. Here's our condition. If f is continuous on this interval AB. So if I have let's do a quartic function that looks like this. That's the whole function. But I'm restricting it to A, comma, B. So you're only taking an interval of a function, and notice it's a closed interval of the function, and it needs to be continuous on that whole interval. Then f is guaranteed to have both an absolute minimum and an absolute maximum. So, for example, on this function, if I've restricted it to this, there's my absolute max, there's my absolute min. If I change my interval, those absolutes might change. So the problem we're now encountering is how do we find out on the interval given to us which one is the absolute max and min. And to do that, we use the candidate test. So the candidate test has 3 main steps. Step 1, find all your critical numbers. Step 2, find the y values for each critical number and the endpoints of your interval, and then pick whichever y value is the biggest. So let's go through and look at a graph example first, and then we'll do an equation example. So here's our graph. We have an interval here. Now note, It's not a closed interval, and we'll talk about that in just a second. But let's start with number 1. What is the absolute maximum of f? The biggest maximum of f, absolute max, we'll do it pink, is right there. That's our absolute max. Now, if it's worded like this, it wants the y value. So the y value at that point is 4. Now let's look at number 2. At what x value does f have an absolute maximum? Well, the x value is -4. Or compare that to number 3. What is the absolute maximum point on f? Well, the point is -4, 4. So notice all 3 of those questions are talking about the same place on the graph, but all 3 of them have different answers based on how the question is worded. And if you give the wrong answer on the AP test, they will dock you points. So please make sure to read the question very carefully. If it's just asking for the absolute maximum, it's the y value. If it's asking for the x value, it's the x value. If it's asking for a point, make sure to do a point. Okay, now let's talk about the absolute minimum of f. We'll do this one in blue. Now, a lot of you would say, well, right there. We have an absolute minimum right there at -2. Because it's the y value. But that's not actually correct. Because -2 does not exist on this graph. It's a hole. -2 does not exist. So, what is the absolute minimum? Well, some of you might say, well, what about -1.9 repeating, Mrs. Johnson? That gets us really close to that point, right? Well, are you ready for me to blow your little minds? -1.9 repeating is equal to 2. And I have a proof to prove it to you. What if I wrote that down? All of you would agree with that, right? 1/3 plus 2/3 equals 1. True. Well, 1/3 is 0.3 repeating. 2/3 is 0.6 repeating. So if we add those together, 0.9 repeating equals 1. They are the same. I'll give you a moment for your mind to melt. So -1.9 repeating is -2. It equals -2. So that is not our minimum. So this problem does not have an absolute minimum. And that follows our extreme value theorem. Because this interval is not closed, it does not guarantee that both of those happen. If the interval was closed, if that was a closed point, then our extreme value theorem would hold. We would have an absolute min and an absolute max. That would be true. But because this interval is not closed, we do not have a guarantee of it. Okay, so let's talk about 5 and 6, and then we'll be done with this video. At what x values does f have a relative minimum? So remember, a relative minimum is just lower than all the points near it. So right there, that's a relative minimum, lower than all the points near it. Right here, that's a relative minimum. It's lower than all the points near it. And you'll notice that that second point, x equals 1, is not differentiable. It's a sharp turn, but it is continuous. And that's all we care about for this stuff, is it needs to have continuity. And we actually have one more relative minimum. And it might surprise you. And it's that one. Because that point is lower than all the points near it. That's a relative minimum. So our relative minimums are x equals -3, 1, and 2. Because it is lower than all the points near it. Now let's do our relative maximums. So remember, bigger than all the points near it. It would be that one. It would not be that one. That's not continuous, so that doesn't count. So the only relative maximum we have is at -1. So hopefully that kind of helps clear up some things about relative and absolute and the difference between it. In the next video, we'll go through and use an equation to find some absolute values.